Okay, again, welcome to today is the 11th and it's the 5th of the 11th month. That is November 5th. Uh, I think I said earlier wrong date, either for the physics 10 or the physics 1 when I had them in the morning. I thought I said the 15th. That's why now I'm confused. It's the 5th of the month. It's the third day after the elections when we don't know who's going to be our president yet, which is kind of weird. Okay, but today is Lab 11, which means that we're in great shape now. So I'm going to adjust a little bit the grading options for the labs. Now, for the question that Alicia asked, and I hope to clarify it once and for all, okay? If you decide to do the lab, that lab report is not the complete picture. So you do that lab report, and then I'm going to send you data to complete it for the motor part, okay? So you'll have more than just that lab report. So there is one component which you do on the permanent magnets and also on the electromagnets, and the instructions for them were there. And I think I was clear on this point. In addition to that, there will be another part where you report on the motor, although you're not going to construct it, but you're going to write a report on it, okay? Basically, with the data, comparisons, the principle behind it, and all of that, okay? The third thing that you're going to be required to do, and that is the final. You have to take the final, otherwise you'll get 0 in the final, okay? So those are the three things. So if you decide to do the report, which is not due today, I'm sorry, not due to tomorrow, it's due a week from tomorrow, okay? The 13th of Friday, okay? Friday the 13th, that's the title of a movie or something like that. Anyway, next week, Friday is when the lab report is due. Then I will see that you have marked you're going to do the lab report. I'm going to send you an addendum or an addition to that report that you need to complete also for the motor part, for the last part of the lab, okay? At that point, you have completed the two components of the lab. In addition to that, you have to attend to do the final, okay? So that is option 1. Option 2 is to opt out of the lab completely, opt out of the report, I should say, completely, okay? And decide to build the motor, in which case, again, I will help you if you have problems and you're running into issues, design issues and everything else. After Thanksgiving, when we meet the week after is when you actually do your lab report. You're going to either upload the video, you're going to upload the video actually to show me how you built it, showing yourself, and also demoing it that it works, okay? That you get your grade, and you will be exempt from the final because that's going to count to your final. All of your grades will add up to that point, and you don't have to attend the final. If you attend it, it's really a moot point at that point because you're not going to be getting grades for it. Okay, do you guys understand how this works? I want to really make sure that you guys understand how is that. And it was a question of the day last time around.
So this is all for lab 10, right? Because I didn't attend last week's.
That's only for lab 10, okay? Not any other lab in the entire series has that. From 1 to lab 13, we don't have any option other than this. That's the only option available is for lab 10. Lab 10, you have the option to opt out of it, and that is to build the motor, okay? And then follow the instructions on that. Now, if you don't want to build the motor and you check the mark that I don't care for building the motor, I want to just do the report and be done with it, that is fine. You have another portion of the report that is also due that I'm going to send it to you, okay? So that is also another thing that needs to be completed. In addition to the fact that if you don't attend the final at that point, I'm going to look at your lab report 10 and see that you're required to attend the lab, then I'm going to grade your final. Yes?
And the final, is it a test or I'm not really
Yes, it's going to be a test. It's basically based on the format we've been using, basically on the hypothesis, on how to build an experiment, and how to also actually get up with a conclusion, and how to support your conclusion. Those are the questions that will be in the exam, basically related on how to conduct a lab report. Then also you'll be given data, some basically generic data, where you're going to draw the graphs and also find the trend line, find the slopes and things of this nature. So basically the final is going to be on a lab, how to basically either, first of all, analyze data, and also how to run your report and how to conduct an experiment. So that's the final. There will be more details on the final coming to the final. Basically, that is the only test in this class, and it's part of the overall grade, in addition to the participation in the lab reports. And now the optional project that replaces the final. You guys understand how this is working now?
Kind of. Just I actually need to. I actually need to start the lab from last week. I haven't done it.
Okay.
So to fully understand everything, like which I can opt in for personally.
Okay. So I would recommend, if you did not attend last week, and I know quite a few did not, to go and watch the recording. And if you want to skip ahead, the first thing that you need to do from that lab report is write your name, of course, in the lab report, and go to page 12, I remember, and then opt either in the lab report or do build the motor. You can see the motor that I built in there during that time, and basically see the demo for it and how it works. Now you can go on Google or YouTube or your favorite platform and search for how to build a motor at home, and there is an infinite number basically of ways of doing that. Okay, any way is fine. If you know somebody who works in alternators, basically they rebuild alternators for old model cars, basically where you go and take your car if it's the car doesn't charge anymore. They've actually rebuilt alternators. They also have the same principle. They have all the machines in there, and you can see them how they work. If you have a relative of yours doing that, that's actually easy. Now, a word of caution for those who, since you mentioned that, I don't know where is my wire. If you did not attend last time and you're attending today, and you want to skip ahead, you need a higher gauge wire. Okay, you need, this is a 28 gauge wire. Okay, as you can see from the bottom where it's checked. Okay, this is 28 gauge. There is a 26 all the way to 16 gauge. 16 is super thick wire. Okay, you don't want 16. Okay, you don't want any, you want something higher than 28. 28 or higher, I shouldn't say it higher. There is the 30 gauge, the 32 gauge, those are typical wires for this purpose, okay? In other words, they have to be super thin. Do not go to Home Depot or Lowe's and try to find them, because they don't have this high gauge wires. These are the high gauge wire required. This is the highest gauge I was able to find in Home Depot, and that is a 20 gauge wire. This one also you can get actually thicker than a 20, which is a 16. This works backward, okay, guys. So if you think that 28 is higher than 20, it's backward, okay. So 20 is much thicker, as you can see it in here, than a 28. Okay, so this is a difference between 28 and the 20. 20 is the thick one. 28 is the light one. Okay. So Home Depot sells it as the alarm bell wire, basically. That's what they call it, and it's a 20 gauge wire. And you don't want that. It's too thick. It has a lot of inertia. It's not going to go. As a matter of fact, I tried to build one using it and thought maybe I can get away with it, and I did not. I knew it's not going to work. So I built I wrapped them around the D-cell battery, and then at the end it did not work. Now, you can have your motor run with a 1.5 volt battery like I demoed it last time. This is a 1.5 battery. Or if it doesn't move at all, if you think that's probably not good enough, you might need to try a 9-volt battery, okay, which has more juice in it, or put this more in series. But the trouble with even with a 9-volt battery, this node did not run. So this node did not work for me even with a 9-volt battery. So that's why I wasted, I think, like $4 or something. It was not that expensive from Home Depot on this thing. Okay, so do not try it. I think I got this whole thing from I forgot how much I paid from Amazon. Now, for those who decided to build the motor, and I will send them the links to the things I got myself, so that they have an idea of how much to spend if they decide on it. and say, okay, I probably will go get it from Amazon, or I get it from eBay, or get it from somewhere else. You have plenty of time to build your motor. Usually Amazon ships within a few days. Same thing with eBay. If you have to pay attention to the shipping days. Okay, so that's basically what I'm going to do to give you the also access to so that actually you can go and get your magnets. Magnets are available in everywhere, a lot of places.
Quick question: do you want us to turn in the build the motor by next week, or
You're going to next week. You're going to tell me one of the two things. You're going to tell me if you're going to build the motor. You don't do anything. You just tell me that you're going to do the motor. Okay. If you're not going to do the motor, if you're
do the
not, if you're,
lab?
yeah, you have to do it by next week.
Okay, and then do you want us to tell you that we're going to build the motor in the lab, like without doing the lab?
The lab report. If you go to page 12, are you looking at the lab report from last week?
No.
Yeah,
no.
go to that lab report. I'm sorry.
Okay.
It's on page 11 where we indicate whether we're going to build a motor or not.
Yeah, there is a checkpoint in there. Okay. You're going to submit that form and that's it. Telling me that. Lab 9. Okay, on page 12.
Wait, lab 9 or lab 10?
Lab 9, page 12. Oh, lab 10, lab 10. Let's see. What am I talking about? I'm sorry.
Hold on. Okay. Yeah, I'm downloading it right now. Hold up.
Okay.
Open it quick. I was confused right there.
Okay.
Go. See,
there are two checkpoints.
Page 12,
in there.
right?
I think it's page 12.
11. Choice. Oh, okay. The build and then prefer the report.
Yeah. So if you decide on the build, you check that, put your name, and that's all you do. You don't have to do anything else. Okay. And you can walk home.
Okay.
I mean, I know you're at home, but you can walk to the kitchen. Okay. Okay.
Yeah.
To the kitchen. Continue on it. Okay. So that's basically in a nutshell for lab 10. Okay. So we have lab 11 now. Any questions about lab 10 now? Thank you, Alicia, for the question. We need clarifications. Okay, so we're going to move to lab 11 now. I really have to keep track of where we are, okay? Technically, we still only have 2 more labs, okay? What is my lab 11? Oh, man, I closed it. So let me find it. There it is. Okay, so I have it open. So lab 11 is kind of, should be easy, I guess. I think it should. So where is the, okay, close this, share, and here it is, lab 11. Okay, so lab 11 is all about basically the law of reflection and refraction, okay? So you're going to basically read through the instructions, okay? Usually, as a typical thing, we're going to leave the objective toward the end, okay, so that we know what we're doing, then we're going to come back to it. Don't forget your name, okay? And the names of the people who worked with you. This is in a nutshell what the law of reflection is saying. It says that the angle of incidence is equal to the angle of reflection. So that's what you're going to check. Actually, if we were in the lab, you're going to shine a light on a reflecting material, and you're going to actually measure the incoming light and the outgoing light and do the measurements to fill this table. So this is actually how the experiment works. You have a laser beam in here, a light source in here, and you're going to put a marker with a pencil, okay? And for the incoming, and another marker for the outgoing. Actually, you need 2 of them, 2 here and 2 there, because 2 points can draw a line. Then you connect this line, and you connect the other line, and you draw the perpendicular to the surface, and you're going to check if the incoming light, the incident angle, the angle of incidence is equal to the angle of reflection. Okay, that's what you do in the lab. And you take it for several measurements and you fill out the table. Instead of doing that, we have this link. So I'm going to click on the link. Okay. And when the link pops up, I'm going to stop sharing the screen and share with you the link. Share the link. So this is basically how it looks like, okay? So at this point, it defaults to 39, and it tells you to use angles between. Let me go back into the lab report. So I need an angle around 30 degrees, an angle around 45 degrees, and an angle around 60 degrees, okay? So I need to change the angle via this thing around 30 degrees. This is around 30 degrees, isn't it? Okay, 31 is good. 30. If you can zoom on it, you're fine, okay? Oh, man, I got it exactly right on the nail in here. 30 degrees, okay? So my incoming angle is 30 degrees. My outgoing angle is 30 degrees. So I'm going to stop sharing 30.03 degrees, okay? So I'm going to stop sharing the screen. I'm going to come back in here to my PDF file, if I can ever find it. What happened to it? Show all. Here. So my incoming angle was 30 degrees, and my outgoing angle, or my reflection angle, was 30.03. Okay? It rounded down, okay? Just leave it the way it is, it's fine, okay? Don't, if you click on it, it's 30.03. So please, when you put it on the Excel file, put 30.03, okay? Because there is an Excel file that you're supposed to download. Let me download it because I really don't know what it is right now. So I need to download it from the same place that you guys download stuff. I know I saved it somewhere in the... no, not this class. What am I looking at? Modules. Lab 11. Open. Open. Because this is so sensitive to the decimal points. So I'm going to stop sharing that screen. Come back in here. Share with you the Excel file now. Note the Excel file has two tabs, okay? There is one for the refraction and there is one for the reflection. Make sure you are in the reflection first, okay? And when you open it, it says 30 degrees for the first one, 30.0. Oops. Enable editing. For some reason, you have to enable, because I just downloaded it. So technically, I should do what you guys are supposed to be doing, namely save it to my desktop. So it's 30. The second one is 30.03 in my measurements, okay? So it says in here an error of 0%. That's fine. Okay, I'm happy with that. So once I fill it out in here, I go back into, let me stop sharing the screen. Let me go back into my PDF file. Where is my PDF file? Here. Then it says 0%. Okay, that's what that formula is telling me. Okay, because if you do 0.03 divided by 30, it's practically 0% error. Okay, so I'm going to stop sharing this screen, and I'm going to go back to the link that they had before. Here, share, and I'm going to find an angle around 45 degrees. Oops, I'm going to find an angle around 45 degrees. Okay, so this is good enough. Okay. 45 degrees, 44.98. Okay, so again, it's going to round it up. Okay, so this seems to be going to give me all zero answers. Okay, 44.98. So practically, there is no difference. Practically, both of them are equal. Okay, so I'm going to stop sharing the screen. I mean, I stopped it, shared it already, stopped it already. Let me go straight to the Excel file. Okay, so it's 45. This was 45. This was 45. You don't have to hit it on the nail for the angles, okay? So this is giving me a big error now, 2%. It's not big. 2% is not really big. So I'm going to go back into my let me stop sharing this screen and go into
I had a question.
share the other screen. Jose, were you trying to say something?
Yeah, I had a question. I'm doing it on my end, and I'm getting 30 degrees for the incident and 30.1 for the reflected, and I'm getting 35% error. So I don't know
Can't
what
be.
that. What was that?
30 and 30.1? It can't be. Hold on. let me go into, if you put, hold on, let me share with you the screen, okay? I know the formula should not give you that big of an error. Okay, what is this thing in here? Share. I'm gonna go back into the Excel file if I can ever find it. Yeah, and everything. Okay, here is the Excel file.
You want me to share my screen?
Hold on. Yeah, go ahead if you want to. I'm having all kinds of stop sharing. Share the screen. Let me see what you did. Did you put it in an Excel file?
Yeah, well, I downloaded this right here. So it's 30, 30.1, and this 35.
Why is it giving you that? Okay, let me stop sharing the screen. Then there is something
You're
wrong
on
here.
refraction instead of reflection.
Oh, you need to go back to the reflection. Thank you, thank you. See in the bottom?
Oh, yeah. Oh, shoot. Awesome. Right.
Thank you for,
Thank you.
put the numbers now.
So, 30. All right. Good.
Isn't it this better now?
Yeah.
Okay. Thank you for whoever caught it. Who was it? Thumbs up. Okay.
Oh, thank you, Samantha.
So this is item 1. Thank you, Samantha. Item 1. Try to remember the discussion thing. What Samantha has mentioned. Make sure when you are in the Excel file, you are on the proper sheet. Okay? Because we don't want to fall into the traps in here. So make sure you are on the proper sheet. If you're doing reflection, make sure you're in the reflection. If you're doing refraction, make sure you're doing refraction. Thank you, Samantha, for bringing a point in here so that we don't fall into this trap again. So I'm going to go back into share the PDF file to get my data in here through. So this thing was 45. This thing was 44.98. And this was a 2% error. Okay, if it's a 2% error, just write it like this. Do not write 2%. First of all, it's not going to allow you to do that, okay? If you try to do it. And do not write 0.0, just write 2, because it says in here percent error already. Okay, just report the number in here, okay? And so on and so forth. It should not really give you 30% error. It should not even give you 10% error. This should be very, very close from the actual measurement. Does everybody understand what we're doing with reflection? Okay, good. Samantha, anybody else? At least one more person. Okay, Alicia is good. So I'm hoping, Sharon is good. So I'm hoping everybody else is on board as far as this part, okay? So let's get going then with the lab report. Let me share with you the PDF file again here. So does the experiment confirm? If the errors in here are below 5%, it confirms it. If the errors are not above 5%, you really have to explain it. And the biggest explanation right now is the fact that the simulation is probably not working well for us, okay? If we are in the lab, then I would be very picky into why did you get so high of an error? Did you not put the normal in the proper place, or did you put something or something like that, okay? So that should be the condition in here, okay? So it really should work, that this angle should match more or less. That's the law of reflection. This is the manual calculations. This is basically, if you don't really trust the Excel file and you want to calculate the error on your own, this is the formula you use, okay? So again, this was part of a big lab that I had before in class. So I'm just changing it to meet the requirements for online basically instruction. And that's why you have this one. If it was in class, I will ask you actually to do the calculation. Now you're being provided basically steps in here on how to do it. So Excel will do it for you, okay? The refraction, there is a refraction because actually there is a change in wavelength, or so that the light basically moves with different speed, if you wish, inside the medium. It moves slower, okay? And the law of refraction is this one, and it's usually between two different media, okay? So the index of refraction of the first medium times the sine of the angle from the medium, the first medium, is equal to the index of refraction of the second medium times the sine of the index of the second medium. Let's plug in now, go to this link. We're going to use basically the lucite in here, which has this specific index of refraction, 1.4896, okay? That is what we know. And we're going to use air from the other side, basically. So we're going to click this thing in here. and I'm going to stop sharing that screen, and I'm going to go back into the page that opens, and it's going to give me this one. I left the coordinate system in here just to show the angles in here, because the angles really need to be somehow measured. But for that, what I'm doing in here, I'm giving you those angles, okay? I'm giving you this angle in here. So this is the index of, this is the angle of incidence. This is the angle of refraction, not reflection anymore. So the beam is coming at an angle in here. For example, this is your incident beam, and it's going to break and go to the other side. Now it's clearly this angle in here from the normal is not the same. This angle is much bigger than this angle. You can clearly do it by, for example, using the hypotenuse in here, which is this distance, and any of the other side, doesn't matter which one. This one, it's clearly 6 divided by the hypotenuse should be the cosine of this angle, whereas in here -6, which is the same distance, 6 divided by this hypotenuse, and it should be clearly that this hypotenuse is bigger than this one, and at the end this angle will be smaller. From the measured values, you're getting 37 degrees, and in here 25.03 degrees, okay? So that's my angle, okay? It says to find also some angle around 30 degrees. So this is 30 degrees exactly. So for 30 degrees, it's 21.3 degrees, okay? So this angle with the normal is about 21.3 degrees, whereas this angle is 30 degrees. So let me stop sharing the screen, and I'm gonna go to the Excel file now. Share the Excel file. Where is the Excel file? Here. And now, to remember Samantha's remark, we should be now in here, okay? Not in reflection, we should be in refraction now. So for 30 degrees, I got 21.3 degrees, okay, in here. And the error is 6%. So this is a big error. But it's fine, it's the simulator that is basically doing a lot of approximations for me and things like that, okay? So let's stop sharing the screen and go back into the simulation. Now I'm going to go around 45 degrees again, similar to the previous one. Again, if you don't have to go 45, I can do 46 or 47, okay? That's fine. So for 47 degrees, I have 30.83. You don't have to hit it on the nail, okay? So the incoming is coming at 47 degrees, and the outgoing at 30.83. So I'm going to go back into here, stop sharing, and go into share the Excel file. So this one was 47 degrees now, 47 degrees. And this one now is, I forgot already.
30.83.
30.83, thank you. 30.83. And the error is 3%, okay? I'm going to do something in here, okay? I'm going to share that screen again with you guys, and we're going to increase the angle. Of course, I know, does everybody understand what's next? There are 2 more angles, basically, for this measurement. And you're going to report that data back into the PDF file. Okay, very good. 2 people, 1 more person at least. Okay, V is good, Alicia is good, so I have more people now. Good. So basically, I'm going to come back into this simulation in here, and I'm going to increase the angle now. Look, I'm going 60 degrees. Look at this one in here. It's 37. I'm going 70 degrees. It's really getting, I'm sending it at almost the horizon. I'm getting 72 degrees now. This one is coming at 40 degrees. And I'm going to go all the way to 90 degrees. So I'm sending it right there, and it's coming at the at this angle, 42 degrees. So I'm not getting, it's clearly this angle is 90 degrees, okay? It's here. And this angle cannot go that high. So there is a limitation, and that is how you find the index of refraction. And so that's basically, so if you're standing in here, okay, and you look and you think the fish is here, because that's where you think the light is coming from your eye, actually the fish is a lot closer in here, okay? And there is a point, if the fish is in here, he's in your blind side. You can, there is no way you can see him in there, okay? Unless you move, of course, in here. so that you can find it. As a matter of fact, if the fish is in here, you're not going to find him at all. You're not going to see him at all. You guys understand? So if you're looking at the pond, no matter which angle you come in here, you're never going to see anything on this side. You're going to see things on this side only. Okay? And there is an experiment that you can do at home with the fraction. You can put a cup of water, okay, and put a nickel in it, or a penny is actually better because you can see the color of it easier. And then stand behind so that you don't see the penny. But somebody starts to pour water in the cup, and as all of a sudden, now because of the refraction, you will be seeing the penny. It's a really fun experiment. If we're in class, we do it together and we enjoy it. Okay? Does everybody understand this? That basically you take a cup and you put a penny in it, and you see where the penny. Put it in the middle. Okay, don't put it in the edge one way or the other. Just put it right smack in the middle. Okay, and then move back. As you can see the penny, at some point you will not see the penny, okay? Make sure the cup is not a transparent cup, otherwise you're going to see it from the side, okay? You're going to, at some point you're not going to see it. Have somebody else, your friend or your brother or sister, pour water in the cup, and as they pour the water, the penny as if starts to appear to you now all of a sudden, and that is because now you have reached this angle of refraction. So that demonstrates beautifully this experiment. Okay, that gives me an idea. Since I'm teaching this class next semester, I'm going to actually do that part of the activities that they demo it and show it to me that they did it. Okay, because we used to do it in class. So that is part of that report. Let me finish the report in here, unless you guys have a question on this. So now I assume that you can finish this table, okay, with the errors and all of that. When you file a report, you don't have to include the Excel file for this one, okay? You just include this stuff in here. Okay, then you're supposed to tell me if there is too big errors, and if there are too big errors, of course, in this case, it's the simulation is not working well. Okay, for the image formation, there are a bunch of questions from question 4 all the way to question, and they're repeating, by the way. They look the same, but they are not, okay? All the way to question, what is it, 17? From 4 to 17, that's 13 questions on this simulation, okay? So let me, first of all, open the link, and explain how this works, okay? Stop sharing the screen. Now share simulation. Okay, it says in the instructions, the first question, choose a focal length of about 1.5 centimeters with what type of mirror is this, okay? So I'm gonna go back in here. The focal point right now is 1. It's easier to move it with the cursor, and you move it this way for the increasing values of the focal points. So I'm gonna have 1 with the not with the mouse, okay? Don't use the mouse for this cursor. Use the arrow from your calculator is easier, okay? Then you can get fine values in here. So we're supposed to get to a focal length of about 1.5, okay? Now, if you don't get exactly 1.5, as long as you're close enough from it, it's 1.5, 1.49, okay? You need to tell me that basically this is the focal point. Now, they say to put the object, which is this one. No, before we do anything in here, the question is, says what type of mirror is this? Here is the answer to that, okay? This is wrong, okay? So this question will have I mean, it's clearly not correct, okay? This is not convex, okay? So when it says convex, please correct it. It should say concave, okay? So this is not correct. I'm going to correct this simulation, hopefully tonight, and post it back again. So this is not correct, but you're supposed to read this thing in here and tell me what it is. This is not a convex concave mirror. It's actually a concave mirror, okay? So let me see if I can find where the math behind it in here, and see if I can correct that. I forgot even how the formula I wrote in here for this thing's in here. The value in here is definitely not correct. Trying to see where it changes to different label. Okay, I think it's this one in here. Hold on. Let me see if I can find the formula for it, okay? Okay. It's in here. Found it. So this one should be concave. And this one should be convex. So now we're in good. We're in good shape. So I don't have to do anything. We did it already. Okay. So let's go back into the focal point of oh man, I'm going in the wrong direction again. Focal points of 1.5. Okay. Okay. Let's keep on moving until I get around 1.49. I mean 1.9, which turned out to be 1.49. Okay, so that's the closest I'm getting in here. So now it says to put the object. So this is correct. Okay, so the answer now is correct. Okay, concave is as if when you walk in it, it's like a cave. So that's basically the answer to the question. So the answer to the question is share. So choose a focal point of about 1.5 centimeters. What type of mirror is this? The mirror is concave. Okay, as you can clearly see from the simulation. Change the position of the object to about 5 centimeters. Okay, we have a bunch of questions in here. So we're going to change first of all. Let me stop sharing the screen. Let me go back into here and put the object around 5 centimeters. So I'm going to click on the object and move it around 5 centimeters. Okay. It's too much. Move too much, and then define motion. You can put it with the arrow back and forth, okay, until you get the correct position. So now it's at 5 centimeters, and it's asking me questions about the image. So the object is blue, the image is red, okay, and it's asking me. Let me stop the question, the sharing. Let me go into the question. The question is the image upright or inverted? So the first thing we need to do is, the first thing we need to do is decide if the image is upright. They call it also in the textbook, they call it erect, okay? Or upside down, inverted, okay? So let's look at the image. What do you guys think about the image, which is the red arrow? Is the image upright or inverted?
Inverted?
It's inverted. So that's the first thing in it. The image is inverted. So that's the first question because it's pointing down and like the object which was pointing up. And then the second part of the question, is it real or virtual? Let me explain what the real and virtual means, okay? When you stand in front of the mirror, the flat mirror, you cannot, basically, the reflection looks like somebody is behind the mirror, okay? But of course you know, and I know that there is nobody behind the mirror. There is no person who looks like you on the other side of the mirror. You guys know that, or this is the first time you learned that? Is anyone surprised that there is no person on the other side of the mirror? Okay, so there is the image. Oh, Jeffrey just found out that there's no other person on the other side. That's okay. The image in this case is virtual. Why it is virtual? Because if I put a film on the other side of the picture, the film will not develop. On the other side of the mirror, the film will not develop. So that is a virtual image. But since the image now, in this case, is in front of the mirror, if I put a film on that side and expose it, it's going to develop an image. So in this case, we call it a real image. So a real image, if you can get really an image out of it, if you can put a film in there, where rays are there. Inverted, virtual image is where you actually you don't get it. So let me go back into the screen and tell you how that is. So this side of the mirror, the back side of the mirror, is basically has a cover behind it, okay? A reflective material, usually made out of metal, okay? all of the mirrors, they have this metal, reflective metals, very usually it's silver, okay? They put that shiny metal so that to reflect that. There is a glass, and glass is not reflective. Glass is actually transparent. So there is a glass in front of the mirror, and behind it, what really does the reflection is the metal behind it, okay? So the rays comes in here, hit the mirror, and bounce back, okay? And they follow the law of reflection. So let me see if I can draw things in here. I can draw. Where's my pen in here? Can I draw? No, I can't. It acts like a mouse now, okay? So the rays come in here, this side, hit the mirror, and bounce back. And when they bounce back, at that point, they form the image. So if I put a film in here, that film will develop. If the image form on the other side of the mirror, that is a virtual image. Virtual image, yes, okay? It's not real. But when the image forms in front of the mirror, that is a real image. So in this case, because the image is forming in the front, is it real or virtual? That's the second part of the question. So what should I put in the answer then? Because this question has two parts. We said that the image is inverted, and the image is it behind the mirror or in front of it?
In front of it.
So it is a real image. Okay?
So it's a real image because it could be developed?
It is real. It's not virtual. And like, for example, when you stand in front of the flat mirror, you see something on the other side, and that is virtual, actually, image. So the image, if it forms behind the mirror, is actually virtual, not real. And like lenses, which actually operate backward, lenses are, the images are real if they form behind the lens, okay? So this is a lens. Now you're looking at my eyes and my, okay? If the image forms behind the lens, as far as I'm concerned, and this side from you, that is a real image. If the image forms in front of the lens, it's actually a virtual image. Those are lenses. Mirrors operate backward. Mirrors, the image will be virtual if the image forms behind the mirror. The image is real if it forms before the mirror. Yes? So you have to pay attention to where the image is forming in this case, okay? Does the image have the same height as the object, or is it magnified or shrunk? Let's go back into it. So for this part, it's going to be real because it's forming in front of the mirror, okay? Let's look at this one. Does the image have the same height, or this less, I mean shrunk, or magnified, or bigger?
Shrunk.
Yeah. So that's that. You answered the question in here for this question. I don't remember what number it is, 5 or something. Okay. So we are done with this one. So let's continue with the second question 6. Question 6: change the position of the object to about 3 centimeters. The same question: is the image upright, inverted? Is it real or virtual? Does the image have the same height as the object, or is it magnified or shrunk? So let's move it to about 3 centimeters. Are you guys still looking at the screen with the object and the mirror and all of that, with the simulation? I can't tell because I'm in the sharing mode. So if I remove the share mode, so can anybody tell me speak up? Okay, very good. So we're going to put it at 3 centimeters. So we have to move it back to this position here, to the left, to about 3 centimeters. Here is 3 centimeters. Look at the image where it's forming. It's almost forming to the same location. Okay. First question: is the image inverted or upright?
Inverted.
Okay. Is it real or virtual? Is it behind the mirror or in front of the mirror?
In front of the mirror.
So it's real. Okay. Is the height the same or less or more than the actual object?
It looks about the same.
Yeah.
Yes, they are the same. Okay. So we're done with this question now. Let's go to the next question. Change the position to about 1.5 centimeters. So I'm going to change the object position to about 1.5 centimeters. So I'm moving it slower, 1.9, 1.5. Okay? Is the image inverted or upright?
It would still be inverted, right?
Where is it?
It got yeeted somewhere.
What happened to it?
It went like out of the screen, right? Like I mean, but it didn't show
Yeah,
on the
it's
other side. So
actually,
uh-huh.
it's not on Earth anymore. Can anybody guess what it is?
Mars maybe with Elon Musk.
It's actually further than that.
The sun? I don't know. I don't know
Further
what
than
direction.
that. Further than the sun. The image is not in the sun actually right now. Any idea?
Jupiter? I'm just gonna say.
It's further than, it's actually anything in the solar system is further than it has gone where nothing can go basically. It went to the other side of the universe at this point. It's at infinity. It literally, and you cannot find it because of the fact that, and now I exaggerated a little bit because the focal length is 1.5, 1.49, and the object is 1.5. It did not reach really the end of the universe, but if it really goes to 1.49, okay, I cannot do it 1.49. That is really where it reaches infinity. It reaches the other edge of the universe, okay? So it's nowhere to be seen in here. So I cannot tell if it's inverted or upright. I cannot tell if it's more or less, okay? I cannot tell if it's a real or virtual. The only thing I can tell is the image is not in the screen. It's gone too far where I cannot trace it, okay? When we do this lab in class, actually it's a lot of fun. You see it moving, and all of a sudden disappears on you. Okay, that is when you know that it's went to infinity. Okay, similar to this one in here. If I just put it slightly bigger number, you see what it is now? 1.7, and now 1.6, 1.5. Okay, it's gone actually. 1.49 is exactly when it reaches the infinity. Okay. So that's basically in a nutshell the answer to it. It says in here 300 centimeters because it's doing the calculation based on this thing in here. Okay, so this distance now is 1.5 centimeters. So this distance is about this much, 1.5 centimeters. Okay, I don't know if you see it or not. So this is 1.5 centimeters. The object and the mirror, and the image is 3 meters away. Okay, according to this calculation. And if you put it at 1.49, this will give you infinity. Okay, this will be it's going to be dividing by 0 basically. Okay. So, and this is a fact of life when it comes to image formations. Let's continue with the next question. Put it at 1 centimeter and see what happened. So the next thing in here, we're going to move actually this one closer, around 1 centimeter. You see when it appeared? It appeared on the other side. Okay. So it went and visited the stars and the other edge of the universe and came back from the other side to the mirror. Okay. So now the question is it upright or inverted? What do you guys think?
Upright.
Okay, we see it upright. Is it virtual or real?
Virtual.
Virtual. This is behind the mirror. Okay, it's on the other side of the mirror. Is it magnified or shrunk, or is it the same height as the object? What do you guys think? Magnified or shrunk or the same height as the object?
It'd be magnified, right? And it's bigger.
Yeah, magnified. Okay.
Yep.
Okay. So this is, I don't remember, I lost track of how many questions were. We're in question 8, by the way. Question 9, choose a focal length. Choose a focal. Oh, man. There's a typo in here in all of these questions. Question, I think, 2 and question 9. Choose a focal length, okay? I'm missing the word length. Hopefully you guys can correct it, okay? Let me tell you what I'm talking about in here. Let me stop sharing in here. There is an English word in here that is missing in here, okay? So when you're doing this, please make correction to this thing in here by adding the word length in here, okay? Oh man, I cannot even type that now. Length. I'm using the mouse, I am not using the pen, okay? That's why the writing now is worse than the pen. So the focal length to be infinity. Okay, let me show you how to do that. Stop sharing the screen. Share the simulation. Okay, so we're going to choose this one now to be infinite. Okay, so we're going to move this one in here until we get. Are we moving it in the wrong? I think. I'm making, yeah. At some point it's going to be negative, but at some point it's going to tell you this is infinite. Okay. You're going to answer this question. That's all. Is the mirror, what type of mirror it is? This is the shape tells you actually what it is. What kind of mirror is this?
Flat mirror.
This is a flat mirror. This is the one that you have in your bathroom. Okay, that's most of the. So that's the question. Then we're going to repeat the cycle again. Basically, we're going to do the 5 centimeters. We're going to do the 3 centimeters. We're going to do the only 2. Okay, we're going to do the 5 centimeters and the 3 centimeters. So let me go back in here. Stop sharing the screen and share with you the animation. So we're going to start with the object at 3 centimeters. So it's as if you're standing in front of the mirror for about 3 centimeters. Okay, the first question, is the image upright or inverted? When you stand in front of the mirror, the other person in the mirror, is he standing up or standing upside down? By the way, the image that forms on your retina, on your eye, is always inverted, okay? Your brain reverses it. So because we're using lenses for our eyes, they come actually with from nature. So when you see, what you're looking at me, actually, when you're looking at the screen, everything is backward, upside down. Your brain reoriented. That's why you can feel your way fine. Otherwise, if everything is, the ceiling is down and the desk is up, so you're going to be confused for a second. Okay, that's how the image forms on your eye too. It's up, it's inverted. But in the mirror, when you look at the person on the other side of the mirror, is he or is she upright or inverted? This is easy enough for you guys to do. Yes?
Yeah.
It's upright.
It's upright, okay. Then we're gonna do,
Yes.
and then it's asking, is it virtual or real? I'm saying in here it's virtual because it's on the other side, the image on the negative side, okay? Is this image magnified or the same or shrunk? In this case, it's, what do you guys think?
The same.
Yeah, it's basically the same, okay? So, and then when we move it up close, it's going to be the same thing, okay? I don't remember what the other measurement. So this doesn't matter where you put it, okay? The answer would be all the questions is the same thing. Doesn't change. Let's change the focal length to how much? -1.5. Okay, so we're going to click on this one in here. We're going to make sure it starts with big numbers, by the way, and it's going to start to shrink until you get it to -1.5 centimeter, okay? -1.5 centimeter. So the mirror changed to convex when this thing in here. So the answers now are correct, okay? So we fixed that problem. So negative 1.49, okay? We're supposed to put the object at 3 centimeters and answer the questions, okay? The image is virtual, and the image is smaller than what it appears, okay? And it's actually, so now when I move it to, and it's upright too, okay? When I move it closer to about 1.5 centimeters, it's the same thing. It doesn't change. The image stays virtual, okay? And it always stays virtual, okay? This is the one that you have on the side of your car. It tells you objects on the mirror are closer than they appear. That is the one that you guys use in your homes, okay? In your cars, okay? I have a bug in my screen. I'm trying to get rid of it. And then there is a last question. Try to find a way to make a real image, okay? Can you ever get a real image out of this? Okay? Even can you change the focal length to something in here, to a negative different number? Can you get an image out of it that is, make it too convex, if you like? See if you can get a real image out of it. Okay? So that is in a nutshell your lab. Any questions? And you answer the questions, all of them, and basically make a conclusion based on your observation. That's it. Any questions? Okay, then unless you guys have questions for me, because I really have to, I have something to do because I have some exams to do. Yes, the question of the discussion was what Samantha basically raised earlier. Pay attention when you're doing your Excel file. Yes, it was only one, Taryn. Yes, okay. Related to paying attention to reflection and the 2 sheets in the Excel file. Okay. So I will see you guys on next week. Okay. I have to prepare some exams for the other classes that are due next week, actually. You guys don't have an exam with me, at least Physics 10 doesn't. But I have exam for the other 2 physics classes. And please send me questions related to this lab or the previous lab until, because the labs are due next week. This is an easy lab, isn't it?
It is.
Okay. Okay, Alicia is so happy. Okay, see you guys next week then.
All right, have a good weekend, Professor.
Thank you too. Bye.